You think time only moves forward because that's just how the universe works, don't you? Past is past, future is future. That's obvious. Drop a cup, it breaks. Wait forever, the pieces won't jump back together. Spill coffee, it doesn't unspill itself. Mix cream into coffee, it doesn't separate back out. Time has a direction, everyone knows this. But here's a question that should disturb you. Why? What force is pushing time forward? What law of physics prevents you from going backwards? What exactly stops broken things from unbreaking? Most people say something vague like, that's just how time works, or physics doesn't allow it. But here's what's going to mess with your head. Every fundamental law of physics works perfectly in reverse. Every single one. Gravity, electromagnetism, nuclear forces. Run them backwards and they work flawlessly. So if all the laws work in both directions, why does time only flow one way? You think you understand why yesterday can't become today, but you've never actually thought about what's stopping it. The answer isn't what you expect. It's not about physics. It's about something far stranger, something that reveals the universe isn't what it appears to be, and your entire experience of time might be built on a cosmic accident. Let me show you what's really happening with time's arrow. Here's an experiment. Get a deck of cards. Shuffle them thoroughly until they're completely mixed up. Now sit down and wait for them to shuffle themselves back into perfect order. All spades together, all hearts together, ace through king. Wait as long as you want. It's not going to happen. But why not? If you're exploring how the deepest mysteries of time and reality work, and you should be, because understanding this changes everything about how you see existence itself, consider subscribing to Reimagine the Physics. We dive into the counterintuitive truths that govern the universe, revealing how the most obvious aspects of reality are actually the most mysterious. Hit that notification bell and share this with someone who thinks they understand why time moves forward. They don't. None of us do until we see what's really happening. Now think about that deck of cards more carefully. There's only one way for the cards to be in perfect order, but there are millions upon millions of ways for them to be mixed up. When you shuffle, you're moving from one organized state to one of countless disorganized states. That's likely. That's what happens. But for the cards to spontaneously organize themselves, millions of random movements would have to coordinate perfectly to create one specific arrangement. It's not impossible. Every individual card movement could happen. But it's so monumentally unlikely that you could wait longer than the age of the universe, and it still wouldn't happen. This is the key to understanding time's arrow. It's not physics that prevents time reversal. It's probability, statistics. The overwhelming number of ways things can be disordered compared to the tiny number of ways they can be ordered. Let's get concrete about this. Take Newton's law of gravitation, the force that keeps planets in orbit. If you have the Earth going around the sun and you film it, then run the film backwards. What do you see? The Earth still goes around the sun in a perfect ellipse. The same laws apply. The areas swept out by the radius are still equal in equal times. Everything works perfectly in reverse. The same is true for electromagnetic forces. Take two charged particles attracting or repelling each other. Run the interaction backwards. It still follows the same electromagnetic laws perfectly. No contradiction, no violation. Nuclear forces? Time reversible. The strong force that holds atomic nuclei together works exactly the same forwards or backwards. Beta decay? Also time reversible as far as we can tell. Every fundamental interaction in the universe is completely symmetric in time. This isn't speculation. It's been tested exhaustively. The universe's basic operating system has no preferred time direction. So why does macroscopic reality, the world you actually experience, have such an obvious time direction? Why do some things happen that never happen in reverse? Let's go back to that broken cup. When it shatters, each piece flies in a direction determined by the physics of the impact. The collision between cup and floor follows the laws of mechanics perfectly. Every force, every acceleration, every trajectory is exactly what Newton's laws predict. Now here's the crucial point. Run the physics backwards and each piece would retrace its path perfectly, coming back together to form the cup again. The laws of physics work both ways flawlessly. Every force that pushed the pieces apart would pull them back together if you reversed all the velocities. But here's the problem. For the cup to spontaneously reassemble, every single atom and every single piece would have to move in exactly the right direction at exactly the right moment with exactly the right speed. Trillions of atoms would have to coordinate perfectly without any external organizing force. Think about the numbers involved. A coffee cup contains approximately 10^24 atoms. That's a trillion atoms. For the cup to spontaneously reassemble, each of these atoms would need to move in precisely the right way at precisely the right time. The probability of this happening by chance is so small that mathematicians don't even have convenient ways to express it. The cup has one way to exist as a cup, but it has an astronomical number of ways to exist as broken pieces. When it breaks, it moves from the one ordered state to one of the countless disordered states. For it to unbreak, it would have to accidentally find its way back to that one specific ordered arrangement from among all the disordered possibilities. It could happen. The laws of physics don't forbid it, but the probability is so small it's effectively zero. Not impossible, just so unlikely it will never happen in the observable universe's lifetime. This same principle governs everything you think of as irreversible. Why doesn't spilled milk flow back into the glass? Not because physics prevents it, but because there's one way for milk to be in a glass and millions of ways for it to be spilled across a table. Why doesn't smoke flow back down a chimney and turn into wood? Not because combustion can't reverse, but because there's one way for carbon atoms to be arranged as wood and astronomical numbers of ways for them to be scattered as smoke and ash. Why doesn't cream separate out of coffee by itself? Not because mixing is irreversible, but because there's one way for cream molecules to be segregated and countless ways for them to be mixed throughout the liquid. The pattern is always the same. Ordered to disordered is likely. Disordered to ordered is astronomically unlikely. But let's make this even more concrete with a simple example you can visualize. Imagine you have a box divided in half by a removable barrier. On one side, you put 100 red balls. On the other side, you put 100 blue balls. Everything is ordered. Red on the left, blue on the right. Now you remove the barrier and shake the box. What happens? The balls mix up. After some shaking, you have red and blue balls randomly distributed throughout the box. This is disorder. Now continue shaking and wait for all the red balls to accidentally end up on one side and all the blue balls on the other side. How long would you have to wait? With only 200 balls, the probability of them spontaneously segregating is about 1 in 10 or 60. That's vastly longer than the age of the universe. And that's with just 200 balls. Real objects have trillions of particles. The probabilities become so small, they're essentially zero. Now let's apply this same thinking to heat. Touch something hot, then touch something cold. The heat flows from hot to cold until everything reaches the same temperature. This seems natural, obvious. But why doesn't heat ever flow from cold to hot spontaneously? At the molecular level, heat is just the random motion of atoms. Hot objects have fast-moving atoms, cold objects have slow-moving atoms. When they touch, the fast atoms bump into the slow atoms, transferring energy. The fast atoms slow down, the slow atoms speed up, until they're all moving at the same average speed. But here's the thing. Every individual collision between atoms is perfectly reversible. If you could reverse every atomic velocity simultaneously, heat would flow backwards, from cold to hot. The physics allows it. The laws of thermodynamics don't forbid it. So why doesn't it happen? Same reason the broken cup doesn't reassemble. There's one way for all the fast atoms to be in the hot region and all the slow atoms to be in the cold region. But there are astronomical numbers of ways for fast and slow atoms to be mixed throughout both regions. When heat flows from hot to cold, you're moving from an organized state, energy concentrated in one place, to a disorganized state, energy spread evenly everywhere. For heat to flow backwards, trillions of atoms would have to accidentally coordinate so that all the fast-moving ones end up in one region. It could happen, but it won't. This same principle explains why you age. Your body maintains incredibly complex, organized structures, cells, tissues, organs, against the natural tendency toward disorder. But this requires constant energy. You eat food, breathe oxygen, and use the energy to repair damage, replace worn-out cells, and maintain organization. But the process isn't perfect. Over time, small errors accumulate. DNA gets damaged and isn't perfectly repaired. Proteins get misfolded. Cellular machinery wears out. The organization that defines your living body slowly degrades, and that degradation is aging. Could aging reverse itself? Could damaged DNA spontaneously repair itself? Could worn-out cells accidentally reorganize into perfect condition? The physics doesn't forbid it, but the probability is so astronomically small that it will never happen. Your memories work the same way. Your brain maintains organized patterns of neural connections that encode information about your past experiences. But maintaining these patterns requires energy. Without constant maintenance, they would decay into random neural noise. This is why you remember the past, but not the future. The past is encoded in the current organized state of your brain. The future isn't encoded anywhere because it hasn't happened yet. There's no organized pattern to preserve information about events that haven't occurred, and here's something that should completely change how you think about free will and decision-making. When you make a decision, you feel like you're causing something new to happen, creating a change in the world that wouldn't have occurred otherwise. But from the perspective of entropy, every decision you make is just another step in the universe's march toward greater disorder. When you choose to get up from your chair, you're converting the organized chemical energy in your muscles into the disorganized thermal motion of heat. When you speak, you're converting organized neural activity into disorganized sound waves that dissipate into the environment. Even thinking burns energy. The electrical activity in your brain generates heat as a byproduct. Every thought, every decision, every moment of consciousness is part of the universe's irreversible slide toward maximum entropy. This doesn't mean your decisions aren't real or don't matter, but it does mean they're embedded in a larger physical process that has a direction. The universe is set up so that organized systems naturally evolve toward disorganization, and consciousness exists in that flow. But this raises a deeper question. If everything tends to become more disordered over time, how did anything get ordered in the first place? Why do we ever see organization if the natural tendency is toward chaos? Here's where it gets really strange. The only way our observations make sense is if the universe started in an extremely ordered state. The early universe must have been highly organized, low entropy, with everything neat and separated. And since then, it's been falling apart, getting more disordered, more mixed up. Think about what this means for stars. Stars exist because matter was once more organized than it is now. In the early universe, matter was more evenly distributed, but with small variations. Tiny regions slightly denser than others. Gravity amplified these variations over billions of years, pulling matter together into stars and galaxies. But this process only works because the universe started in a special state, neither perfectly uniform, which would be maximum entropy and couldn't form structures, nor completely clumped, which would be unstable and would quickly disperse. It started with just the right amount of organization to allow structure formation. The cosmic microwave background radiation that we observe today is the afterglow of this early organized state. It shows us a universe that was remarkably uniform but with tiny temperature variations, exactly the kind of organization needed to eventually form the complex structures we see today. The same is true for life. Life exists because chemical elements were once more separated than they are now. The early universe created conditions where complex molecules could form and maintain themselves against the tendency toward disorder. But this only happened because the universe began with low entropy and the energy sources to drive organization. Your memories exist because your brain was once less disordered than it would be if left to random thermal motion. Your neurons maintain organized patterns that preserve information about past states, but only because your brain continuously expends energy to maintain these patterns against decay. Everything you see, everything you experience, is the universe slowly dissolving from its original ordered state into maximum disorder. We're living in the aftermath of cosmic organization, watching it decay. The deep truth about time's arrow isn't in the laws of physics. The laws are perfectly time-symmetric. The deep truth is in the initial conditions. The universe began ordered, and it's been getting disordered ever since. That's why time seems to flow in one direction. That's why you remember the past, but not the future. That's why causes precede effects. That's why you age. That's why things break and don't unbreak. But here's the really disturbing part. We don't know why the universe started ordered. This isn't explained by any physical law we know. The laws of physics work the same forwards and backwards, so they can't explain why there's a preferred direction to time's arrow. We have to add something extra. The assumption that the universe began in a special, highly organized state. This is perhaps the deepest mystery in all of physics. Why did the universe start with low entropy? Why was everything initially organized rather than maximally disordered? We don't know. We just observe that it did, and we can trace all the apparent irreversibility in the universe back to this mysterious initial condition. Some physicists have suggested that the Big Bang itself was the source of this initial order. The rapid expansion of space in the early universe may have stretched quantum fluctuations into the macroscopic variations that eventually became galaxies and stars. But this just pushes the question back one level. Why did the Big Bang produce a low-entropy universe rather than a high-entropy one? Other theories propose that our universe is part of a larger multiverse and that only universes with low initial entropy can support the kind of complex structures that give rise to observers like us. In other words, we exist in a low-entropy universe because only low-entropy universes can produce beings capable of asking why they exist in a low-entropy universe. But these are speculative ideas. The fundamental fact remains. We don't know why the universe started ordered. We only know that it did, and that all the apparent irreversibility we observe traces back to this mysterious initial condition. Consider what this means for everything you think you understand about cause and effect. You assume causes come before effects because that's how you experience time. But the fundamental reason isn't in the nature of causation itself. It's because the universe happened to start ordered, and maintaining order requires energy, while creating disorder happens spontaneously. When you push a book off a table, you're not causing it to fall in any deep sense. You're simply introducing a small disorder into the book's organized state of rest. The book falls because falling represents a more disordered state than sitting still. There are more ways for the book to be on the floor than balanced on the table. The cause is just you nudging the universe toward greater disorder. When you remember something, you're not accessing some special backward-flowing information. You're observing the current ordered state of your neurons, which preserves information about past ordered states because your brain evolved mechanisms to maintain patterns longer than random thermal motion would normally allow. Every arrow of time you experience, memory, causation, aging, decay, traces back to the universe starting in an improbable ordered configuration and evolving toward maximum disorder. This changes everything about how you think about the nature of time. Time doesn't flow because of some fundamental property of space-time. Time seems to flow because we happen to live in a universe that started organized and is becoming disorganized. Consider what this means for everything you think you understand about cause and effect. You assume causes come before effects because that's how you experience time. But the fundamental reason isn't in the nature of causation itself. It's because the universe happened to start ordered, and ordering takes work, while disordering happens spontaneously. When you push a book off a table, you're not causing it to fall in any deep sense. You're simply introducing a small disorder into the book's organized state of rest. The book falls because falling represents a more disordered state than sitting still. There are more ways for the book to be on the floor than balanced on the table. The cause is just you nudging the universe toward greater disorder. When you remember something, you're not accessing some special backward-flowing information. You're observing the current ordered state of your neurons, which preserves information about past ordered states, because your brain evolved mechanisms to maintain patterns longer than random thermal motion would normally allow. Every arrow of time you experience, memory, causation, aging, decay, traces back to the universe starting in an improbable ordered configuration and evolving toward maximum disorder. This changes everything about how you think about the nature of time. Time doesn't flow because of some fundamental property of spacetime. Time seems to flow because we happen to live in a universe that started organized and is becoming disorganized. In a hypothetical universe that started in maximum disorder, there would be no arrow of time. Events wouldn't have preferred sequences. There would be no distinction between past and future, no causes and effects, no memory, no aging, just random fluctuations with no overall direction. But our universe is special. It began with an enormous amount of order that's still in the process of dissipating. We exist in the middle of this cosmic transition from order to disorder, and that's why we experience time as having a direction. The universe is like a vast organized system that was wound up at the beginning and is now slowly unwinding. Every process you see, stars burning, planets cooling, life evolving, thoughts thinking, is part of this unwinding. We're living in the entropy flow, riding the wave of increasing disorder. And here's the final strange implication. Eventually, the universe will reach maximum entropy. Everything will be as disordered as it can possibly be. Stars will burn out, black holes will evaporate, and all matter will be distributed uniformly throughout space at the same temperature. When that happens, there will be no more arrow of time, no more aging, no more memory, no more cause and effect, just random thermal motion with no preferred direction. But that's billions upon billions of years in the future. For now, we're still living in the echo of whatever mysterious process created the universe's initial order. Every second that passes, every memory you form, every decision you make, is part of the universe's slow march toward maximum disorder. You can't go backwards in time not because physics forbids it, but because you're part of a cosmic process that started organized and is becoming disorganized. To reverse time would require the entire universe to spontaneously return to a more ordered state, and that's so statistically unlikely it will never happen. Time's arrow isn't built into the laws of physics. It's built into the initial conditions of the universe, and those initial conditions remain one of the deepest unsolved mysteries in all of science. Every moment you experience is part of this vast unwinding, this cosmic decay from order to disorder. The universe is running down, and nothing in the fundamental laws requires this. The laws work the same forwards and backwards, but the universe started ordered, and we don't know why. Subscribe to Reimagine the Physics if you want to keep exploring how the deepest assumptions about reality turn out to be the most mysterious. The more you understand about time, the stranger it becomes. And the stranger it becomes, the more you realize that the universe you think you live in might be completely different from what it appears to be. You can't unlearn this now. Every time you see something break, every time you watch cream mix into coffee, every time you remember something from your past, you'll know you're witnessing the universe's slow decay from its mysteriously ordered beginning. Time doesn't move forward because it has to. Time moves forward because the universe started wound up, and it's still unwinding. And the reason it started wound up? That's the mystery that might hold the key to understanding the deepest nature of reality itself.